Welcome to my YouTube channel. This is Ramani Online Mathematics. Today we are going to look at solving exponential equation using logarithms. Is that okay? Now, when we were dealing with the exponential equation, I made mention of something. I said that before you can solve an exponential equation, then either they have the same base, then you create the powers, or they have the same powers, then you create the what? The base. Now let's look at an instance where they have different base and different what? Powers. Something like this. How do you solve this particular question? There's no way that you can make the base what? Be the same. If you can do that, you can leave yours in the comment section for me to see. This is base 2, this is base 5, power x, power 1. We can't make this one and that be the same, or this and that be the same. So the only alternative here is to take log on both sides. So if I want to solve this, I'll take log on both sides. So please, taking a log, you can decide to take log with base 2, base 5, base, any base that you want. But the popular one that we have been using is the base 10. And I've already explained to you that for the base 10, we don't write the 10 there. So here will be log 2 power x. So it's base 10. If you like, you can write it. You can also leave it. And here too will be log 5. Like you can write the base 10. Is that okay? You cannot take this side to be log base 10 and here become log base 20 or log base 2. It must be the same. Whatever that is here should be the same as this side. Is that okay? Now looking at this particular point, you realize that there's one law that we looked at, that if I have log a x y, I can write this one as y log a power x, or x base what? A. So this one we have 1, 2, 3. 1, 2, 3. So I can bring the x down. That will give me x log 2 base 10 equals log 5 base 10. Now looking at this, I want to find my x. If I have something like this and I want x, I divide both sides by what? 2. So here too, if I want x, I divide both sides by the log 2 base 10. So I have to divide here by log 2 base 10, log 2 base 10. Then when I do that, you see this and that are the same, so they will go. So I have my x to be equals to log 5 over log 2. You can decide to bring the base 10, they are the same. So here, what you do is that you simply put this one in your calculator, and the calculator will feed you with a beautiful answer. So when you do that, I have 2.3219. So this is how we use the logarithm to solve exponential equation. Now let's look at this example. Solve the exponential equation. Solve the exponential equation. 4 to the power 3x minus 1 equals to what? 8. Approximate your answer to 4 decimal places. Okay, so let's see how we can solve this question. We have 4 to the power 3x minus 1 equals 8. I can easily send this one to that side. That will give me 4 to the power 3x equals 8 plus 1. So here, 4 to the power 3x is equals to 9. Now, let's check if you can make the base and that of the base here to be the same. There is no way. What of the powers? Can you make the powers be the same? No. When you find yourself in such situations, what you do is that you take log on both sides. So I'll take log on both sides. I've already said that this will be base 10. That's why I don't write it. So here will be log 9 base 10. So to be base 10, 4, 3 times x. And you have to apply this log here. How do you apply the log? You simply bring this 3x to become the coefficient of the log. So I have 3x log 4 equals log 9. Now I want only x to be the dependent variable. So I want the x to stand alone. So you simply divide both sides by 3 log 4. Let me repeat the question. 3x log 4 equals log 9. So I have to divide here by 3 log 4. 3 log 4. So you see this one and that will go, leaving my x to be log 9 over 3 log 4. Now the question says we should leave our answer in what? 4 decimal places. That means you have to leave your answer in decimals and run it to 4 decimal places. So you put this one in the calculator and you have your x to be 1.58496. So therefore our final answer for x will be 1.5850. So 4 dp. Alright, so this is what we have. This is what we have. Now let's move to some complex one. I hope we saw some complex ones when we were dealing with the exponential equation. So let's also look at it here. Find correct two decimal places. 2 decimal places. The value of x for which 5 to the power 2x minus 5 to the power x plus 1 plus 4 equals 0. This is a very nice question. So let's see how you can go about it. 5 to the power 2x minus 5 to the power x plus 1 plus 4 equals 0. So looking at this, I can write this one as 5 to the power x all to the power 2. If you remember from laws of indices. In fact, if you have forgotten this, you can go and check my previous video on laws of indices. And this side will give us 5 to the power x times 5 to the power 1. So you see the base are the same. When you add the powers, it will give us this. So that will give you the same thing, equals 0. Now if you look at this one and that one are the same. They are very the same. So what you do here is very simple. You let's say y to represent the 5 to the power x. So it means that whatever I get here, whenever I get to this side, I replace it by what? Y. And there's a square, this going to be y squared minus 5 times y, because 5 to the power x is y, plus 4 equals 0. Now this is what we have. And if we get this, this is a quadratic what? Equation. How do you solve this? So I'm going straight here. I have y minus 1 y minus 4 equals 0. Which means that our y is equals to 1 or y equals what? 4. Now let's go back to this side. At y equals 1, because the question was given in terms of x, and now we replace the x by what? Y, so we have to send it back. You can't just leave it like this. So anytime you do something like that, you have to do back substitution. So at y equals 1, let's replace this y by 1, equals 5 to the power x. Voila! If you remember, I told you that any non-zero number to the power 0 will give you 1. So if you look at this one, here is base 5, so I want to make the base what? The same. So I can write this one 5 to the power 0. It's still 1, which is equals to 5 to the power x. Meaning that my x equals to 0 because the bases are the same. We simply equate the powers. Now looking at the other side, at y equals 4, then I have my 4 to be equals to 5 power x. Now this side, I don't know the magic that we are going to do or the mathematics that we are going to do to make the base what the same. So the only thing you do is to introduce the logarithm on both sides. So if I introduce log on both sides, I'm going to have log 4 equals log 5 power x. So looking at this, I can let the x become the coefficient of log 5. So I have x log 5 equals log 4. So I divide both sides by log 5. That will give me log 4 over log 5. Very, very nice. But the question said you should leave our answer in what? 2 decimal places. Okay? So what you are going to do is that for 2 decimal places, you have to convert this one to decimal. Already, this x equals 0 will be rejected. Why? Because we don't have 0 logs, just like negative logs. So when we're dealing with the logarithm, I told you that the base of it should be always greater than what? 0. Alright, so now looking at this particular thing, if you put this one in calculator, this one we are going to have x is equals to 0.8613. So our final answer will be 0.862 dp. The question is to leave our answer in 2 decimal places. Now try this and leave your answer in the comment section. So for x in the initial equation, 4 to the power 3x minus 2 equals 26 to the power x plus 1. I think this is a very nice question that you can try at your leisure time. Please try and leave your answer in the comment section. Thank you for watching. I hope this is very helpful. Share to your friends, your colleagues, your wives, your husbands, and your. Thank you very much.